Hey everyone, this is Shivam and this is our project called BlockSquid. So the BlockSquid is a blockchain project in which we are using blockchain and computer vision to monitor the water usage and identify the flow rate and water quality based on its color. And not only this, the main purpose of using blockchain is to prevent the tamperings that happen during these cases of water industries, those industries which has a heavy usage of water, like steel industries or water parks. So this project mainly focuses on storing fetching the real-time data using a computer vision algorithm and storing it on the blockchain within a given time limit. So let's go and check out the code we have implemented this all in our own blockchain protocol. So as you can see, this is the very basic. We have used object-oriented programming to make the code easy and more readable. And yeah, like we have different functions, for example initializations, then creating blocks, then getting the previous chains, and then generating a proof of work which is non-symmetric. We have used references, and the two major references in our project was AZ data science, especially this blog, and this GitHub link by Ants94, thanks to him. So let's go back to the project, and these are the implementations which we are using. And here are the two types of water, dirty water and the fresh water, and these are some random names. So, and yeah, we can just comment it out. This was just for the testing purpose. Let's go next. And so these coordinates are fetched from another program which I'll be showing you shortly. That is to get the exact point, to select the region of interest and accordingly perform computer vision algorithms. So this is to skip the initial background frames when the water is not flowing. Okay, let's move next. So this is the one to process the frame and get the results. And finally here comes the blockchain part. So as you can see, this is the blockchain part. So let me go to the command prompt and just show you the demo. Okay, this is blockchain version 1.5. This is implemented in Flask in a local server. So as you can see, we are ready to go. Now I'll just open my Postman and the web UI. So the web UI is very basic version of the implementation on how it will look and everything. So I'll just go to the web and find out. So this is the basic UI. Currently we are just focusing on one industry, but we are planning on, in future we are planning to have multiple industrial authentications and everything. So this is a very basic UI. So yeah, we have two elements currently, get chain and mine block. We have tried implementing others also, but these are the major focus ones at the moment. Okay, so I'll just first show you the very basic chain which has no data. So this is what we get. This message is the main element where we embed everything. So NA00, NA is one is the industry ID, the other one is the water type, then this one is flow rate, and finally we have the discounted like the credit which gets generated. Okay, so if I try to mine a block, what happens in this process is data is sent to the server and this process gets executed here. Like this frame is captured using this thing. Just a second. Okay, I mean this here the frame gets captured, and you can see here we are using CamRead, which is a computer vision function from computer vision library. We have declared it to a demo video at the moment because in webcam I cannot actually show flowing water in that sense, but this demo video we are capturing frame by frame, and whenever we mine a block we send a frame and accordingly that frame is analyzed and we get the results. Okay, so here you can see data sent to the server, I'll just mine few more blocks, like, and depending upon the time gap, whenever we mine a block, then at that moment the image is captured, so we can accordingly set the times. Okay, so till now I'll just see how long is my chain. So as you can see, this is my chain. As you can see, this is the company ID, which is fixed at the moment, Freshwater, then the flow rate in square pixels per second, and finally the discount index, and it's the length of the chain is 4. Okay, so I'll just try to fetch data. So as you can see here, I have this data with timestamp and credits earned and the water flow rate. And now if I try to again mine some more blocks to get some latest data, I'll just mine few more blocks, and as you can see now, I'll be having a bigger chain which is of 8, whose length is of 8. So if I refetch the data, as you can see now, I'm getting some other data. So this is all our project, and as I have navigated you through my blockchain implementation, I'll just navigate you through the other part, like computer vision and everything. So this particular code, I have added comments to make you understand better, but I'll run this one also just to show you. I'll just kill my program in case it creates any problem, which should not be creating, but still. So as you can see, this is my frame, and whenever you want to select the ROI, you have to press R on your keyboard. So as I press R, I am getting this ROI selector. You can select the ROI. If you're not happy, you can select it again, and you can, once you are happy, like this should be my region of interest, like this is the point from where water will be continuously passing, and this is the point at which I want to calibrate everything. So select it and press spacebar. So you'll get the coordinates, and these are the coordinates which I used in the main program, this one. So here these points. Okay, so I have set it XYZ. These are the coordinates which are fetched from here. Depending upon different type of video, it can be fetched. And one thing to note, make sure is that camera should be static for this entire computer vision operation, because that is one important factor for the algorithm to work. Okay, so this one was the second one. Then the third is type of water determination. So this is a code to, like, based on the different types of water we are using. I've just used a very small data set which we have created. So freshwater, this is the data set for the freshwater. Based on the color properties, a histogram comparison is being done. So that is one. And then where is the wastewater? This is the data set for the wastewater. This is a very tiny data set, because within the time frame we had this, but it gives pretty much decent results because it's mostly color based. So that code training part can be done at this point. This one here, we just need to add the paths, like I showed you the images. We have to add these paths, and accordingly we can classify, and it will be stored as a Python variable data dictionary. We will use pickle to dump it, so that we don't need to do it again and again. Moving next, this is the water classifier. Here we have two functions, water type and flow rate classifier. These two functions are responsible for, the first one is responsible for getting the water quality, that is based on the color, and the second one is responsible for getting the flow rate. So the way it fluctuates from the background image, the square pixels, that can be calibrated to get the conversion between square pixels per second to square meters per second, and then it can be used as a flow rate measuring device. So that is the idea of the water classifier. And yeah, so that is pretty much of all the programs. Other than that, we have just, this is very basic template of how we try to implement the HTML part and the JavaScript part. So this is the JavaScript part in which we are fetching everything. And yeah, so that is pretty much of our project. We tried to implement Near API and had some failed attempts, but at the end we decided to come up with a very basic blockchain protocol, and this is what we have made. I hope you liked our project. and do let us know in case of any question or queries. And yeah, you can always find our all the files are in this particular GitHub repository, which you can refer to. We'll be sharing the link and everything. Thank you very much, guys.